1.4, solve problems using similar triangles. So we're going to use similar triangles, but these are going to be word problems this time. Okay, as a recap, similar triangles can be used to find heights or distances, okay? So lengths that are difficult to measure. And similar triangles have many practical applications. So here are just a couple. Okay, a stick that is 3 meters tall, and I think that they called it tall instead of long because they kind of want you to draw the triangle where like the height is 3, if that makes sense. Okay, it casts a shadow 4 meters long. Okay, a lot of students get this confused. Shadows are on the ground. Put the 4 on the ground. Okay, a nearby tree. So we have some tree. Okay, so we're going to have another triangle. Casts a 15-meter shadow. Okay, so the shadow is 15 meters. We don't know the height of the tree. It just says a nearby tree. That's it. What is the height of the tree? So let's label this ABC. Let's go DEF. And let's first state that triangle ABC is similar to triangle DEF because of angles. Okay, we have this angle in here that's going to be 90 degrees. We always assume that if something is, like say standing up, it's standing up straight, which is perpendicular to the ground. Okay, and then we always assume that like if the sun is in the same spot, our shadows are going to have the same angles. Okay, so angle A equals angle D, angle B equals angle E, and then angle C equals angle F. Okay, so because of angle, these two triangles are similar. As soon as we state that, we can use similar triangles. So let's go big over small. DE over AB equals EF over BC. Okay, and let's sub in. So we have H over 3 equals 15 over 4. And all we have to do is cross multiply the 3 up. So 15 times 3 is 45. We divide that by 4. And we get 11.25. So this is measured in meters. Because this is a word problem, we have to put a therefore statement. Therefore, the height of the tree is 11.25 meters. Okay, to find the length of a pond, a surveyor took some measurements. She recorded them on this diagram. What is the length of the pond? So again, there's many practical applications to similar triangles. This being one of them, it's going to be very difficult unless you're in like a boat to measure PN, right, which is the length of the pond. But because we can use similar triangles, we can go ahead and measure it. Okay, so let's go ahead and state our similar triangles. Okay, so let's start with the 90-degree angle, so P. And we'll go up to like up the short side, which is L, and then down to K. Okay, and that's going to be similar to start at the 90, which is P, go down to M, which is like the short length, and then the long length or the hypotenuse, because we're talking about a right angle triangle, we can then say N. So these two are going to be equivalent. We can, or sorry, I should say similar. We can prove this by angle. Okay, angle P equals angle P. Okay, this is because of opposite angle theorem. This is right angle, so then this is right angle. Okay, and then L equals M. So angle L equals angle M. And that's all we need. We don't need to write out all three. So therefore, these triangles are similar. Therefore, similar. Okay, and now we can actually start our question. What is the length of the pond? So we have PN that we're looking for. So we have a bunch of side lengths. Let's put the big triangle over the little triangle. So let's go PN over PK. Okay, and then PM over PL. So we have Pn over 12, right? Pn over 12, then we have 5 over 3. Okay, so it's a 5-to-3 ratio. We cross multiply, we get Pn equals 60 over 3. Let's bring this up here. Pn equals 20. Okay, this is measured in meters. And because this is a word problem, we say, therefore, the pond is 20 meters long. Example 3. Tim is 1.5 meters tall. So this would be Tim, and he would be 1.5. Okay, tall is vertical. He stands 20 meters in front of a tree. So here's the tree and here is Tim. So from here to here is 20 meters. Just be careful that you don't label this entire side 20 meters because it's only from the tree to Tim. Okay, and so when he says he and casts a shadow, so he casts a shadow of 2.5 meters long. So from Tim to the end of the shadow is, 2.4 meters. Okay, that means that this entire side is the 20 plus 2.4, so 22.4 meters. Okay, so the question is, how tall is the tree? Okay, so if we wanted to label this, we could say A, B, C would be the big triangle, and then D, E. Okay, so we have triangle ABC, okay, and we're going to use similar triangles. ABC goes in this pattern, okay, from the top to the bottom, like to the 90, to C, and then DEC. Okay, so it's going to be similar to DEC. So to prove similarity, we can do angle, angle. So we know that B and E are going to be the same because they're both going to be 90 degrees, right? Perpendicular to the ground. So angle B equals angle angle E. And they share angle C. So angle C, of course, equals angle C. So therefore, by angle theorem, these are similar. That means we can use similar triangles and solve for how tall the tree is. So let's call the height of the tree H, okay? And usually I do the big triangle over the little triangle. So we'll go AB over DE, okay? And then BC, this entire length, so BC over EC. And then we want to sub it. So I have H over 1.5 equals 22.4 over 2.4. Right? Because the EC is just this length right here. Okay, so if we were to cross multiply, we cross that up, we get H equals 33.6 over 2.4. I'll bring this up here. H equals 14 meters. So because this is a word problem, we want a therefore statement. Therefore, the height of the tree is 14 meters. Example 4, determine the length of H. So H is here, again, this is the height. So we have triangle ABC. Okay, so triangle B is going to be in the middle there, triangle ABC. Okay, and we want to say that this is going to be similar to DFC. If you notice that I put these backwards, it's because the letter in the middle represents the right angle in the triangle, and then C and C are opposite of one another. Okay, so to prove similarity, we can use angle, angle. So angle B, which is 90 degrees, is going to be equivalent to angle F. Okay, and then angle C and angle C, because we're assuming that these go up on the same slope. So angle C equals angle C. The reason why we can assume that they go up on the same slope is because it's like a mirror image, right? There's a mirror there. So therefore, similar. Okay, so let's go ahead and set up the ratio. So we're going to have AB over DF equals BC over FC. And when we plug in, we'll get H over 150. so h over 150. And then we get BC, but the problem is we have 150 and 120 in centimeters. So we need to actually convert these 18 meters into centimeters, right? We talked about how the purpose of similar triangles is to solve for like objects or things that we can't get to. So we have a really good estimate. So we multiply 18 by 100. There's 100 centimeters in a meter. We get 1800 centimeters. Okay, so 1800 in the numerator, and then we get 120 in the denominator. Okay, cross multiply, I get h equals 270,000 over 120, and I get h equals, so we can either say 2250 centimeters or 22.5 meters. Okay, this really isn't a, like there's a diagram here, but this really isn't a word problem, so we don't have to go ahead and put a therefore statement.